Yeah, we are back on chemical properties. It's question number 4 in a normal question paper. Like in this case, is also question number 4. They are saying the flow diagram below shows how propanol 2-ol can be used to prepare other organic compounds. A, B, and C represent the organic compounds, while 1, 2, 3, and 4 represent 4 organic reactions. Because this section mainly deal with reactions and their reaction conditions. Now let's analyze what is on the flow diagram before we can answer the questions. We're starting from an alcohol. Alcohol can undergo 2 reactions, remember, substitution and addition and elimination, sorry. Now if we add HBr, meaning that this is substitution, and if we are moving from here to here, we are adding concentrated sulfuric acid and heat. Therefore this side is elimination. Now meaning that compound S is an alkene, in this case alkene, which will be propene. Now this one, because Br will be going to number 2, then we'll have 2-bromopropane. And then this one from alkene, if we add hydrogen, therefore compound C is an alkane, which will be propane in terms of the number, the name. Okay. Now moving from haloalkane to alkene, this is elimination. That's where we're going to need concentrated strong base and strong heat. That is the analysis of what is given. Let's try to answer the questions now. We've got 4.1.1. Write down the structural formula of propan 2-ol. Very easy. We start with the prefix prop. 1, 2, 3. The OH is at carbon number 2. Therefore, the rest of the bond will be for hydrogens. That is now 4.1.2. Name the type of elimination reaction represented by reaction 1. Type of elimination, is elimination, therefore we are removing all water there, it will be dehydration. Then 4.1.3. now the UPEC name of compound B. We've already said compound B is an alkene, which is propene. Those who love numbers, they can even call it prop 1 in or 1 propene. 4.1.4. then write down the balance equation for the reaction 2 using structural formulae for the organic compounds. Reaction 2 is the one of substitution. Therefore we'll have propan 2-ol plus HBr forms, it will be now Br will be here plus water. Uh, 415, 4.1.5. They say write down the balance equation for reaction 3 using condensed structural formulae. Reaction 3 is the elimination, therefore we start from your CH3, CHBr, CH3 plus sodium hydroxide. We said we need concentrated base in the presence of heat. Then we're going to form an alkene, which is propene, CH3. It will be now CH, CH2, and then plus. We'll form 3 products, sodium bromide plus water. This will be the balance equation. And then we go for 4.2.1. They say for compound C, write down the structural formula. Compound C, we said, is an alkane, therefore, which is propane, just 1, 2, 3. Then write the structural formula of propane. Structural formula of propane. And then 4.2.2, they say to us, write down the balance equation, balance chemical equation. When it bends in excess oxygen, use a molecular formulae, in this case, for the organic compounds. Then it will be C3H8 plus O2, which is oxygen, forms carbon dioxide. Carbon dioxide plus water. One easy way of balancing the combustion reaction is just to write 2 in front of the organic compound and take the number of hydrogens to be in front of water. Then from there balance carbon, 2 multiplied by 3 is 6, right, 6 here. And then oxygens are the last, 6 multiplied by 2 is 12, 12 plus 8 is 20, divided by 2 is 10. So you can have it this way, that is a balance equation, or you can just have 1:1, 5, 3, 4. Also that will be correct, no problem. So that is the end of this question number 4, which was about reactions. It was in this case 16 marks. I hope everything was okay. Don't forget that when you analyze the table, please just be as explicit as possible, so that at least that will help you in going forward in answering most of the questions here. You see, it was very easy now to answer questions because of the analysis, to say we know type of reactions, we know their reaction condition, even though they didn't ask, but that one is not taking it away from us. Next time it will help us a great deal, so our knowledge is broadened by doing that. That's one typical organic reactions or chemical reactions. Remember, there are 5. Just in a nutshell, just to close the mouth. 1 is oxidation, as I said, as we said, oxidation or combustion. That's where the organic compound react with oxygen to form carbon dioxide and water. Then you just know 2 things that it's about. This one is an exothermic reaction, and then you must also know how to balance it. File number 2 is esterification or condensation. So an alcohol react with the organic acid to form, in the presence of sulfuric acid, and heat to form ester and water. And know the reaction conditions I've already mentioned, and know that all esters are formed from primary alcohol. That's very important, that one. And number 3, it's about those 3 types substitution, which we have got 3 types. I think I'll expand in the next session. And we'll move from single bonds to single bonds. Then number 4 is elimination. We've got 3 types as well that are examinable of elimination. We are moving from single bonds to double bonds. And then number 5 is addition reaction. We are moving from double bonds. Every time when we move from double bond, wherever we are going, that will be addition reaction. Therefore, we have got 4 types of addition reaction. Just have to know them. Very important, there are only 2. Your hydration and hydrogenation. Here, the 2 important, dehydrogenation, especially dehydration, where you need reaction condition. And then in this case is from haloalkane forming an alcohol. That's a very important one. So because that's where we'll need dilute sodium hydroxide. So for now, let's just pause, and then we'll get to know this better in the next sessions. Thank you. Bye.